Problem 10. We have a kingfisher that dives at an average speed of 4.6 meters per second. So it's flying through the air at 4.6 meters per second towards the water. The time it spends in the air is 1.4 seconds. Again, it's diving straight down. They want to know the distance or the height from which it traveled. How do we know which formula to use? Well, we have speed, we have time, we have distance. It's obvious we have only one formula that satisfies all these variables. It's speed equals distance over time. Now, I don't like it the way it stands. I want to rearrange it. You should be able to do this. To get rid of time on the right, simply multiply both sides by time, and you land up with distance is equal to speed times time. I rearranged the equation because it's easier for me to write it this way. Now all you need to do is plug in the variables, S for S and T for T, of course, and you'll land up with how far the bird was in the air for. Now the confusing thing could be, again, distance. They didn't ask for distance, they asked for height. And don't forget, height is the same thing as distance. Let's go on to number 11. It was a dark and stormy night when suddenly saw a flash of lightning. 3.5 seconds later, you heard the thunder. Well, what do we know? They tell us the speed of sound is 340 meters per second. They also tell us the time is 3.5 seconds, or 3.5 seconds later. They're asking us how far away. That means the distance. How far away was something? We don't know what it is. Here's our variables. What formula can we use? What formula have we been using all along? Speed is equal to distance over time. It's not arranged in the right way, so either you can look at your formula sheet or you should know how to manipulate this formula. You're going to multiply both sides by t. T will disappear on the right hand side, and you have t times s is equal to d. I rather write the single unknown on the left, so I just rearrange it. It's my personal choice. Distance is equal to speed times time. And like anything else, it's time just to plug and chug away. So time is equal to 3.5, s is equal to 340. I'll let you do the detail work. Let's look at number 12. A kangaroo can hop at 65 kilometers per hour. They want to know if this kangaroo hops for 3.2 minutes, how far did it go? I immediately notice there's a discrepancy between hours and minutes, so we might as well change either minutes to hours or hours to minutes. It doesn't make any difference. I'm going to get rid of hours with the speed. It seems more convenient to me. So for every 1 hour, there's 60 minutes. You're going to cancel out the hours, and you land up with 1.08 minutes, or sorry, kilometers per minute. Now, not to get confused, I'm just going to get rid of 65 kilometers per hour. It's just no reason to see anymore. If I'd have a pencil, I would erase it. I just scratched it out. So I'm not going to use 65 kilometers per hour for anything anymore because I don't need it. So get rid of it. Take it away. What's the distance? Well, what formula can we use? We have speed, we have time, we don't know distance. Let's use our old friend that we've been using for the past few problems. Speed is equal to distance over time. And again, we don't know what the distance is. Rearrange the formula. Distance is equal to speed times time. And again, I will leave you to plug and chug. Number 13 is a little bit tougher of a problem. Recall from your reading, the average speed is the total distance you traveled divided by the total time. To solve this problem, calculate the distance the finch traveled on the tortoise and add it to the distance the bird actually flew. So now you know the total distance. Once again, the distance on the tortoise, that's distance t, is equal to s of the tortoise, speed of the tortoise, times the time that the tortoise was crawling. And now we need to find how far the finch flew. So it's going to be the distance the finch flew is equal to the speed of the finch, make sure it's not a t, that's f for finch, times the time the finch was in the air. Now if you add these two distances together, distance on the tortoise plus the distance on the finch, you will have the total distance the bird traveled. So once again, the distance on the tortoise plus the distance on the finch, and you have distance total. So now we know how far this animal moved. We also know how long it was in the air, we also know how long it moved for, and it was 2.4 minute time interval according to your book. So all you need to do is apply this to the formula we've been using. We know the distance, we know the time. So the average speed for this trip was the total distance divided by the total time. Hope that makes sense. We'll find out later in the week.